Okay, objective 24. We talked about two words that are very important. They are and or. What did we say that the word and meant?
Overlap.
And meant overlap. It's the overlap between two inequalities. So if you put the two inequalities on the same line, what we're really looking for on and problems is where do those inequalities overlap? Or means something different. What is or? We're going to put them on the same line. Remember, just like and, we put them on the same line and say where they overlap. On or, we put them on the same line, but do we care about overlap? What do we care about?
Everything that's shaded.
Everything that's shaded. I just want to know what numbers get shaded. So we're going to take everything or take all. Or means take everything. Anything shaded or take all. So if I put the two things on the same number line, they may overlap, they may not overlap. I don't care. I just want to know what numbers end up getting shaded. So I'm going to take everything that gets shaded and call it the answer. On the and, I'm going to graph both of them, and I'm not taking everything. If I've got one going this way and one going this way, I'm just going to say, well, where did those two arrows overlap? Now the last thing here is sometimes you have what I call a three-headed monster. It looks like this. These things will look the same every time. They are always going to look like two connected dots. If you wanted to graph this, you put a solid dot at -2, you put an open dot at 5, and you connect those two dots. So three-headed monsters, or compound inequalities that look like three pieces, are always two connected dots. So they always look like two connected dots. Kind of like a barbell. You have two dots and they're connected. But just knowing that, when you're doing these problems and you have multiple choice, you should automatically see two answers that are not going to have a chance at being the right answer. So when this first one pops up, and all three of these on this page are the three-headed monsters. So you got -4 is less than or equal to x is less than 5. This three-headed monster. This should be two connected dots. Look at answer C. Do you see two dots being connected? No. Arrows go apart. So it won't be C. What else will it not be?
D.
Won't be D. It's always going to be two dots connected. Now you've got to get those dots right. The dot at -4, should it be solid or should it be dotted? Solid. So -4 should be solid, and then what about 5? Open. So we got a solid dot, or a filled-in dot, and an open dot. So which of these two has the filled in
B.
at -4? B. So here we got the filled in at -4, and we've got the open at 5. That one you didn't have to do any work. It was just, here's the problem, identify the graph. You don't have to add anything, you don't have to subtract anything, you don't have to multiply, you don't have to divide. It's just make sure you get the right dots and they're connected. On example 2 and 3, on these monsters, you're going to have to take care of the coefficient on x. So when you got a 3 on x, how do you get the 3 off of the x? Divide all three sides by 3. So divide all three things by 3. And that looks sloppy, but those are supposed to be 3's. What's -9 divided by 3? -3 less than or equal to x. Less than or equal to 12 divided by 4. Right. So I need two dots. Oh, I guess I should go right here so you can see it. I need two dots. One at -3 and one at +4. What kind of dots? Both. Closed. First off, it can't be A or C because those aren't connected dots. It's got to be B or D. But I want them to be both closed, both connected. So it's going to be B. Now on this last example, I left a little more room because you're going to have to do a little bit more. You're going to have to add something. You're going to have to divide something. Before I even start it, I want to point right here. This is a negative number on your x. That means at some point you're going to have to divide it off. So at some point you're going to have to do what with your signs? Flip them. Keep that in mind. It's unfortunate. This makes it ugly. But that's going to happen when there is a negative coefficient on x. But before you even do that, you should add something everywhere. Here's x. I want to get x by itself in the middle.
Whenever you add it to everything, do you even add it to the -12?
Yeah. Add 12 here. Add 12 here. Add 12 here. Instead of having a left and right side like normal, now you have a left and a middle and a right. So you have to add 12 to the left. add 12 to the middle, add 12 to the right. Okay, negative 4, I'm going to come down below these answers. Negative 4 plus 12 is 8, less than or equal to negative 4x is less than 16. At this point, I want to divide my coefficient off of the x, so I need to divide all three sides by what?
Negative 4.
Negative 4, which is going to cause a lot of sign flips here.
So it'll be negative 2.
Negative 2 greater than or equal to x is greater than negative 4. Now, one thing that I did mention last week is that your three-headed answers like this will never have greater than signs. It will always go smallest to biggest. So when you have greater than signs like this, we've got to get them flipped. So you flip this whole thing. Flip the whole thing. So we start out with negative 4.
So whenever you flip it, they still stay whatever they are, like negative or positive?
Yeah, so this negative 4 goes here. Then the sign with it, and the x. So negative 4 is here. This sign comes with it. X is in the middle. This sign, and then negative 2. So you have two connected dots here. Negative 4 and negative 2. Which one is going to be solid? Negative 2. So make sure we have the negative 2 solid. As in negative 4, open. Negative 2, solid. Negative 4, open. Negative 2, solid. Okay, that whole page was what some of the three-headed monsters look like. The next page is ands and ors and fancy notation. I know at some point some of this stuff popped up, really confused us when you saw something like this. All this is here, this little squiggly and x and that line right there means for all x on this problem, I want it to follow this rule. X is greater than negative 3 and x is less than 4. Done. So it's fancy notation to make that statement happen. For all x on this problem, x better be better than negative 3 and x better be less than 4. It's fancy notation. The problem is right here though. Alright, to the right of this, put a number line. To the right, with your pencil, put a number line. 0 in the middle. Okay, I am going to graph both of these on that number line, and this is an AND problem, so what am I looking for?
Overlap.
The overlap. X is greater than negative 3, so negative 3 is over this way. What kind of dot do I get? Open. And if it's greater than, which way do I go?
Right.
The right. Now, instead of doing the shade thing as much, I'm really just going to do an arrow that kind of floats above and kind of goes this way. Hey, there it is. Going to the right. I started at negative 3, go to the right. I need an open dot at 4. Open dot at 4. Now, if I am less than 4, which way do I go? Left. So I'm going to put an open dot at 4, and I'm going to go left. I'm going to kind of hang out below the graph here. This is an AND problem. So I have to ask, where does it overlap? Does it overlap here, maybe at negative 6? Is there overlap in?
No.
What about here at negative 4? Is it overlapping at negative 3? It's kind of like starting to get ready to. At negative 2? What about over here at 3?
No.
What about here at 5? No. So basically, everything from here to here is overlapped. So from here to here is your answer. There's overlap happening from negative 3 to 4. So we want to choose from negative 3 to 4. Both of them are open dots. So we want to make sure from negative 3 to 4 we have open dots. Not like A or C. Right here, from negative 3, positive 4, as in D. That's what we're looking for. Okay, 2 OR problems coming up. Now, on example 5 right here, we don't have to work anything out. It's all done. No adding, no subtracting, no multiplying, no dividing. We just need to put them both on the same number line. And then what do I care about if it's an OR problem? everything that's shaded. I don't care about the overlap. I care about what numbers get shaded. If it's shaded by one line, that's good. If it's shaded by both lines, that's still the same good. It's just good. X is less than -1. Here's -1. I'm going to put an open dot. And if it's less than, which way do I go? Left. So I'm going to kind of just float above. And I'm going to say, there we go. I went that way. X is greater than or equal to 4. So right here. Not greater than, so right.
Yeah.
Oh, greater than or equal to. Yeah, so it is close. Now, if this was an and problem, I would have a problem. Because do these things overlap? No. So if this was an and problem, I would say, I got nothing for you. You want overlap? I got no overlap. But it's not an and problem, it's an or problem. I just care about what gets shaded. It looks like everything left of -1 is shaded. It looks like everything greater than 4 is shaded. And that's it. I don't care. They don't overlap. They don't have to. Which graph kind of looks like that? Yeah, A. From -1 to the left, and from +4 to the right with the right kind of dots, open and closed. They don't have to overlap. All right, here's an or problem. And now on these next two, you got to do some work on each of them. So we have to work this out. Then we got to work this out. Also keep in mind this. What does this mean right here? Yeah, a sign flip. What about over here? Sign flip. Take a second. See if we can get both those worked out really quickly. We're gonna draw a number line. We're gonna work it out. Okay, if you notice something really quick that happens on this, what happens when you add 8 to both sides?
Cancels out.
And it turns into, what's -8 plus 8?
0.
0. Okay, so you have -4x is greater than 0. You still got to divide by -4. You still have to flip your sign. It's going to be 0, but you just need to understand it's not greater than 0. Now it's sign flip. It's less than 0. 0 divided by -4 is still 0, but you had to do it because you had to flip your sign. Likewise, on this one, just flip the sign, divide by -3. X is now greater than +3. -9 divided by -3 is 3. So X is greater than 3. Okay, so come over here to the right. Sketch a number line. X is less than 0, so I put a dot where?
0.
And where do I go? All right, and then I'm going to put a dot at 3. And where do I go? Right. Okay. And that's it. So it looks a lot like D. They both go opposite directions on an OR problem, that's fine. Put the dots and go in opposite directions. Example 7, you're back to and. And means what? Overlap. 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 So let's work them both out. Work them both out. Notice here, positive, positive, no sign flips needed. So you work both of these out. What's the first thing I'm going to do?
Add 2.
3x greater than or equals 6. What's the next thing? Divide by what? So one of them tells you x is greater than or equal to 2. The other one's really easy. You just need to do what to both sides? Add 5 and you're done. So x is now greater than what? 4. Alright, is this an and or an or problem? So I'm looking for overlap. On this first one, I want to put them both on the same number line. So greater than or equal to 2. Close dot, I'm going right. Greater than 4. Open dot, I'm still going right. Both arrows going the same direction. So start to think, does it overlap here at 2?
No.
What about at 3?
No.
What about at 4?
Yeah.
It kind of starts to. Everything to the right of 4 seems to have 2 lines.
Yeah.
So it's overlapping at 4. What about if I went further, like over here at 10? Would it still be overlapping?
Yeah.
So everything right of 4 seems to be overlapping. So we want to put on our final answer an open dot at 4, because that's where we kind of started overlapping. And then everything right of 4. I would believe you could convince me that everything right of 4 probably has 2 arrows on it. So everything greater. A couple things to remember. And, when you have an and, what does that mean?
Overlap.
Overlap. If you have an or, what does that mean?
Everything.
Take everything. And then if you are trying to graph a 3-headed monster, what should you expect it to look like?
2 dots together.
2 dots together. So just glancing at the first page, which was all 3-headed monsters, you could say, hey, there's no way, if this is a 3-headed monster, there's no way it's this one or this one. On the second one, there is no way it's this one or this one. On the third one, there is no way that it is this one, and there's no way it's this one. Because you need 2 dots connected for all your 3-headed monsters. All right, that is it. That's objective 25.